Last episode, we mapped the whole injection family. Today, we go deep on the most famous, most rewarding member of it, and we get our hands dirty. This is SQL injection, end to end. We're going to find it, confirm it, and then extract an entire database step by step. By the end of this episode, you'll understand exactly how an attacker turns a single vulnerable parameter into every username and password in the system. Everything here runs in a safe, legal practice lab. Fire up your lab, and let's pull a database apart. Quick recap of the idea. SQL injection happens when an application builds a database query by pasting your input directly into the SQL text. Because the database can't tell your data apart from its own instructions, you can inject fragments of SQL that it will run. Last time we saw the concept. Today it's all mechanics, the exact payloads, the exact process, the exact way you go from I think this is injectable to here is the admin password. This is the workflow real bug hunters use every day. First, the ground rules, because this matters. You practice SQL injection only in environments built for it or ones you have explicit written permission to test. There are fantastic free labs for this, the PortSwigger Web Security Academy, DVWA, which stands for Damn Vulnerable Web Application, and OWASP Juice Shop. We'll work against a deliberately vulnerable lab app with a product page that takes an ID in the URL. That ID parameter is our way in. Never ever run these payloads against a site you don't own or aren't authorized to test. Step 1. Find the injection point. You look for anywhere your input reaches the database, a product ID, a search box, a filter, a login. The first test is beautifully simple. You add a single quote to the parameter and watch what happens. If the page throws a database error, or breaks, or behaves strangely, that single quote just broke the SQL syntax. That's your first strong signal that whatever you type is landing inside a live query. One little quote is where almost every SQL injection story begins. Now confirm it properly and understand what you're dealing with. You test the logic. Add something always true like or 1 equals 1 and see if you get more results. Add something always false like and 1 equals 2 and see if the results vanish. If the page content changes based on your true and false conditions, the database is evaluating your input as code. Confirmed. You've proven injection and you've learned the app reflects the query's results, which tells you which extraction technique to reach for first. Before you attack, picture the query you're inside. For a product page, the backend is almost certainly doing something like select name, description, price from products where IB equals your input. Your job is to figure out the shape of that query, how many columns it returns, what data types they are, and where the output lands on the page. Once you can see that invisible query in your head, injection stops being guesswork. You know exactly what to close, what to append, and what to ask for. The most powerful extraction technique is the union attack. The SQL union operator lets you take a second separate query and glue its results onto the first ones. So if the original query returns product data, you can union on a query that returns, say, usernames and passwords, and they appear right there on the product page. Union-based injection is how you turn a boring product lookup into a window that shows you any data in the entire database. But union has two strict rules you must satisfy first. Rule 1. Your injected query must return the same number of columns as the original. So step 1 of any union attack is finding that column count. 2 is you inject order by 1, then 2, then 3, increasing the number until the page errors the last number that worked is your column count. Or you inject union select null, then null adding nulls until it succeeds. Null is your friend here because it's compatible with any data type. Nail the column count and you're halfway to reading the whole database. Rule 2, you need to know which of those columns actually shows up on the page. So you replace your nulls with markers, put a recognizable string or a number in each column position, then load the page and see which markers appear. Those visible columns are your output slots, the ones you'll use to pull real data out. Now you have everything the union needs, the right number of columns, and the exact positions where your extracted data will be displayed back to you. Time to actually take something. Now, you interrogate the database about itself using a special built-in database called information schema. It's a catalog that describes the whole database, every table name, every column name. So through your visible columns, you query information schema.tables to list all the tables, and you spot the interesting one, something like users or accounts or admins. Then you query information schema.columns for that table to learn its exact column names like username and password. You've just mapped the database's structure without any prior knowledge of it. This is the payoff. You now know the table is called users and the columns are username and password. So you craft your final union, select username, password from users, load the page, and there they are, every credential in the application displayed right on the product page you started from. You can concatenate them neatly, page through them, and dump the entire user table. From one quote in a URL parameter to the full credential list. That's the complete union-based SQL injection kill chain. Not every app is so generous with visible output. Sometimes the page shows nothing useful, but it does leak database error messages. That's error-based injection. You craft a payload that deliberately triggers an error which contains your data inside the error text. For example, forcing the database to convert your query's result into a number it can't handle, so it complains, and the error message codes the value you are after. When an app is verbose with its errors, you can extract data one clever error at a time. Now the hardest and most common case, blind injection, where the app shows no results and no errors at all. You can still win by asking yes or no questions. This is boolean-based blind. You inject a condition like, is the first letter of the admin password greater than M? If it's true, the page loads normally. If false, it looks different. Maybe a product vanishes. So the page itself becomes a one-bit answer. You binary search each character, letter by letter, reconstructing the data purely from how the page behaves. Slow, but unstoppable. And when even the page content doesn't change, you got one final lever, time. This is time-based blind injection. You inject a condition tied to a delay. If this is true, then sleep for 5 seconds. Now you ask your yes or no question and simply watch the clock. If the response takes 5 seconds, the answer is true. If it comes back instantly, it's false. The server's own response time leaks the data. It's the slowest technique of all, but it proves you can extract a database from a target that gives you absolutely nothing to look at. Doing blind extraction by hand is painfully slow, so for real work you automate with sqlmap now that you understand what it's doing under the hood. You feed sqlmap the vulnerable request, and it handles everything, detecting the injection, identifying the database, finding the column count, and running the exact union, error, or blind technique automatically. Point it at a lab parameter, ask it to dump the user's table, and it reconstructs every row for you. The manual skills you just learned are what let you guide sqlmap and verify that what it reports is real. Let's not forget the quickest win of all, authentication bypass. On a vulnerable login form, you put your injection right into the username field. Something like admin, single quote, then or1 equals 1, then a comment marker. This turns the login's where clause into a condition that's always true, so the database returns the first user and logs you straight in, usually as the administrator with no valid password. It's the simplest SQL injection payload there is, and on an unprotected login, it's still devastatingly effective. SQL injection can go far beyond reading data. Depending on the database and its permissions, an attacker may be able to write files to the server, read sensitive files off the disk, or with stack queries, run entirely separate commands. In the worst cases, SQL injection becomes full remote code execution, complete control of the server. This is exactly why a single SQL injection flaw is treated as critical. It is very often not just a data leak, it's a foothold into the whole system behind the application. Real targets fight back with filters and web application firewalls that block obvious payloads. So hunters adapt. If spaces are filtered, you use comments or alternatives in their place. If keywords like union are blocked, you change the case, or use inline comments to break the word up. You can URL encode, double encode, or use a database's own functions to obfuscate. The code injection never changes, only its disguise. Learning to reshape a payload past a filter is a huge part of turning a blocked attempt into a working exploit. And the fix, because you recommend it in every report, SQL injection is almost entirely solved by one practice, parameterized queries, also called prepared statements. Instead of gluing input into the query text, the code sends the query structure and the user data completely separately, so the input is only ever treated as a value, never as executable SQL. Add least privileged database accounts and input validation as defense in depth. But the headline is always the same. Use prepared statements and this entire class of attack largely disappears. Take a step back. You just swap the full SQL injection kill chain, find it with the code, confirm it with true and false, map the query, count the columns, find the visible ones, enumerate the schema, and dump the data with blind and time-based methods for when the app hides everything. This is one of the highest value skills in all of web security, and now the mechanics are yours. Practice it in the labs until the workflow is muscle memory. That fluency is exactly what separates a scanner runner from a real hunter. So that's SQL injection from a single quote to a full database dump entirely in a safe lab. You've now got one of the most powerful techniques in the field, along with the responsibility that comes with it. Use it only where you're authorized. Next episode, we take the same hands-on energy to the other giant of injection, cross-site scripting. We'll craft real XSS payloads, steal a session in the lab, and see how attacking the browser works in practice. Subscribe so you catch it and tell me, did you dump your first database following along? See you in the next one.